Hey guys, this is Kerry, and in this video we are going to be talking about regression curves and doing part of today's lesson. So you've done the do now, we talked about the correlation coefficient, hopefully at this point. So we're going to jump into the regression curve examples that you've been provided with. So the first question says, use the data below to answer the questions that follow. So we're given a table of data, x and y, and we're given an x and y graph, or axes. It says graph the data on your calculator. Notice it's not a perfectly linear fit, or notice it's not perfectly linear, but still close to linear. So to enter this data in on your calculator, you're going to be pressing the Stat button. You're going to be editing, so you can press Enter on option 1, Edit. This takes you to the place where you can type in two different lists, L1 and L2. This is going to be our x value, this is going to be our y value. So let's enter them. 2, 3, and I like to enter all the x's first, because for me I can just press enter in between. Now you press the right button, and you can scroll over. 3, 5, 6, and let's say you make a mistake here, and you type the wrong button, 2. I had a hard time clearing this, but if you press the delete button, it will clear the entry entirely. So you can replace that with the correct value, 9. Now, we've got our data entered in on the calculator. So the next step is to graph the data. If you just press the graph button, nothing shows up. And the reason why nothing shows up is you need to enable the calculator to graph your scatter plot. So the way that you do that is you're going to do this stat plot option. So second, y equals. That takes us to this menu where we have options, well, without going too far in depth, we want to use plot 1, and we're going to just turn it on. Press enter where it says on. It might look slightly different on yours because mine is a updated version of the calculator, but just turn it on. And now that it's on, you can press graph again, and now you'll be able to see the data. Although on your calculator, it will probably be black and white. So now we've got the data graphed. It is not perfectly linear. It's close to linear. So what we're going to be doing is we're going to be using a linear regression to find the line of best fit for this data. So your answer should be, so what we're going to do is now, using the calculator, we're going to find the equation of that line of best fit. So here we go. To do that, press second quit. All of the regression fits that we're going to be doing today are located in the same place that we entered in the data. So press stat. Now we're not going to be editing the data, we're going to be using that data to do a calculation. So scroll over to the calc menu, and I think you can pick probably which one of these choices would be best to do a linear regression. Maybe it's a little confusing actually, because it looks like option 4 and option 8 are both called linear regression. We like our lines in the form mx plus b, so we're going to choose option 4. Press enter. And now your menu is going to look a little bit different. You're going to get to this place, and it's just going to pop up on the screen, linear regression, and then you'll just press enter. I have to press enter a couple of times, but after doing that a number of times, this is what comes up. So the equation of our line of best fit is actually, it looks like y equals, and then they tell us that a is 1.9, so we should plug 1.9 in here, 1.9x, and then b is negative 0.9, so it should be y equals 1.9x minus 0.9 for the y-intercept. Now we've got the equation of our line with the coefficients rounded to the nearest tenth. So one thing that you might think is missing is, well, how do I determine the quality of my fit? I'm missing the regression coefficient r. And there's an option that you can use on your calculator, and we probably should have done this before, but I think it's helpful to see what it looks like without this option turned on, so that you can see the benefit of turning this option on. So to turn this option on, we're going to go second, quit. And then we're going to go into the catalog that contains all of the functions on our calculator. Second, catalog. Now the option that we're going to turn on is called diagnostic on. If you press the button that corresponds to green D, that will take us to the D part of the catalog. And now we'll scroll down to the part that says diagnostic on. So if you press enter, it'll pop up on your screen, diagnostic on. You have to press enter one more time. Now we turn the diagnostic on. So now if we go and we do the regression fit again, we'll be able to see the R value to tell us the quality of the fit. So here we go. To do the regression fit again, we go stat, calc, linear regression. This is going to look a little different for you, so just press enter once, I think. For me, I have to press it like 4 or 5 times. And now when you do that, because you've turned the diagnostic on, it's going to give you information about the quality of your fit. So for us, the quality of our fit is R equals 0.981155781. We're going to be using R, not R squared. If you want to round that to the nearest thousandth, R equals 0.981. This is a pretty good fit. Now, it might be helpful for us to actually see the data on our calculator and the line of best fit at the same time. So to do that, we're going to go back to the graph. Now, to make the line appear, what we're going to do is we're going to leave the stat plot up, but we're going to go into the y equals menu, and we're going to type in the equation of the line we just found. So this will be your answer to part B. For me, I wrote it down as 1.9x, you should have the same thing actually, minus 0.9. Now press enter, and go to your graph, and what you should see is you should see a line, the regression line, just like in the do now problem, passing through the cloud of data, through the center of the cloud of data, almost, approximating the general trend of the data as it was plotted. So it looks like a pretty good fit, which is indicative of what the R value said as well. All right, so we're going to go on to option 2, but we've done a lot to our calculator. We put in a bunch of data, we changed the stat plot thing, we added an equation to y equals. So what I'm going to do first is I'm going to do a reset on the calculator, so second quit. And to reset your calculator, it says these directions in the last problem of the lesson, but I'm going to do it now. So second, memory. We want to reset, so we do option 7. We want to reset all of the RAM, so choice 1, and then reset RAM, choice 2. And this is a nice thing to do after you do a big problem like this, because now your calculator is back to its initial configuration. All right, so for option 2, I know right away that I'm going to want my R value to appear. So the first thing I'm going to do is I'm going to turn the diagnostic on. That way I don't have to do the regression twice. So second, catalog, diagnostic on. Here we go. Oop, I overscrolled. It's easy to click too many times on this thing. Here we go, press enter, diagnostic on. Enter one more time to run that code. Now the diagnostic is on. So the regression coefficient, the correlation coefficient, R, will appear on the screen. Next up, we need to graph this data. So to enter the data into the calculator, we press the stat button. We're going to edit our list. Notice that they're empty because we reset the calculator. So to edit our list, we'll put in 0, enter, 1, 2, 3, 4. Next, we're going to put 390, 201, 97, 52, 20. So to graph this data, if we press graph, nothing appears on the screen, which is unfortunate. So what we're going to do is we're going to turn the stat plot on. So second, stat plot. Click plot 1. It might look a little different for you, but just turn it on by pressing enter on the on option. Now that it's on, press graph, and we should see our data. Oh crap, we don't see our data. So why don't we see our data? Well, the reason we don't see our data is look at these y values. These y values are off the screen. They're way too large. So to get the right y value, what we're going to do is we're going to adjust the window that's shown here. So press the window button. And now if we look at our x values, it looks like we're going from 0 to 4. So I'm going to change x min to 0. I'm going to change x max. Actually, I like to leave x max at 10, going a little bit past the end of the data, because maybe we can see the broad trend. X scale, we're not going to change. We're going to leave that. Now the y scale is the one that was really problematic. Our y values go from 390 to 20. In general, if they're all positive, and they're all close to, or some of them are close to 0, it's sometimes nice to start at 0. So I'll start at 0. And now for y, I like to go a little past the highest value, similar to what we did with x. So I'm going to go up to 400 here, a nice round number. Just like we left x scale alone, we're going to leave y scale alone. Now let's take a look at our graph with this new window. All right, great. So we can see all of our data points just like we did before. Now this data does not look linear. In fact, it should remind you of the stuff we were talking about in our last lesson, or not last lesson, but last unit. It looks like an exponential decay graph. So this time when we fit the data, we're going to go to the stat menu. We're going to click calc. But instead of using a linear regression here, we're going to use an exponential regression. So let's scroll down to our exponential regression. is not even on the screen yet. There's a number of different regressions here that will be useful for us. Oh, I passed it. There's the exponential regression, so press enter. I think for you guys, it's just going to be press enter right away. Your screen will look different. I have to press enter 5 times here. A little bit of extra work, but it's okay. And now after doing that, we get an exponential regression equation. So it has the form y equals a times b to the x power. And then it fills in these a and b values for us, just like it did before. So for us, our equation is going to be y equals 410 point, and it doesn't say what's around the coefficients to this time, so I'm just going to round them to the nearest thousandth, 410.266 times 0.482 to the x power. Now, because we turn the diagnostic on, we get some information about the quality of the fit. The quality of the fit is very strong. It's almost 100% accurate through the data. So we know we have a good fit for our equation. But maybe it's helpful to see that on our graph. So remember, to see that on our graph, we have to actually put in the equation, just like we normally would, of the curve that we just found. So we go y equals, and the curve we found was 410.266 times 0.482, all to the x power. Yep, I'm pressing the wrong button here. All to the x power. All right, so let's press graph. And now we see it really nicely, almost passing through that data. So this should be a really helpful introduction to a skill you will need to have on the regions. A couple things to check for. You want to make sure that you reset your memory when you're done with the problem, so you don't have any extra data on there that's messing up future graphs. And you also want to make sure that you turn your diagnostic on before you get your regression fit. That way you get information about the correlation coefficient and the quality of your graph. So remember to reset your graph, or to reset your calculator, so you're ready for the next problem. Second mem, reset, option 7, all RAM, reset RAM. All right, guys, one of the nice things about a video is you can always go back to parts that were difficult. So if you found any of this difficult, please feel free to rewatch it before you ask a question. And if you still have a question, please ask your question. Bye.